Now we go to 1.6. An equation. It says an equation is a statement that two mathematical expressions are equal. That is called an equation, an equality. So on the left-hand side, you would have an expression, whether it's a polynomial or rational expression. On the right-hand side, you have another expression as a polynomial or as a rational expression. You set these two equal, you have an equation. Give you an example. Here it says 2h plus 7 equal 2h squared divided by x plus 1. This would make it an equation. Actually, this equality here make it an equation, right? Some equations are easy to solve. Some would take a little bit more time to solve. To solve an equation involving one variable, such as this one, the variable is only x, we find the value for which the equation is true. So which means you solve for x, and whatever value you come up, if you plug it back into the equation, the left-hand side should equal the right-hand side. Okay? So it would be equality. It would be an equation. Otherwise, if it doesn't come out the same on both sides, then the answer is not correct. The simplest form of equation is linear equation. Linear equation is when you have a polynomial expression of degree 1. A polynomial expression of degree 1. It says a linear equation in the variable x is an equation that can be expressed in this form. ax plus b equals 0. ax plus b equals 0, right? So on the left-hand side, you have a polynomial of degree 1 because the power of x is 1. A and b are real numbers, and it says a should not be equal to 0, because if a is equal to 0, 0 times x is 0, therefore it shows b equals 0, so b is also 0. If a is 0, b is also 0. Right? So a and b are real numbers. So again, if this is your equation and a and b are real number, well, the way simply to solve it, you keep the term with x on one side and take well, let me do it different. This is what the book does. To both sides of this equation, I'm going to subtract a b. So ax plus b, I'm going to subtract the b from this side, and 0 minus b to the other side, right? Since we are adding or subtracting the same term to both sides of the equation, nothing would happen to the value. So b and minus b would cancel. So here I would have ax equals 0 minus b is minus b. Now I'm going to divide both sides of the equation by an a. So this divided by a, this divided by a, this a and this a would cancel. Therefore, x would be equal to minus b divided by a. Okay, so that's simply, again, a and b are real numbers. So you can see that in the numerical example a little bit clearer. Now, what we are saying, again, let's do this one. What we are saying is, if for x in here, I go ahead and plug minus b divided by a, the left-hand side would be equal to the right-hand side. So let's go ahead and do it. In place of x, I'm going to put this value I found. So the a times minus b divided by a plus b. We say this should be equal to 0. You can see this a and this a would cancel. Therefore, I would have minus b plus b. And minus b plus b is equal to what? They cancel each other. That would be 0. So the left-hand side is equal to 0 for this value. value of minus b divided by a. So it's really easy to prove by plugging in back the answer you found. In solving linear equation, these properties are very important, even nonlinear equation. These properties are very important to understand. It says let a, b, and c be real numbers. If a is equal to b, then a plus c and b plus c on the right hand side, they would be equal, and a minus c and b minus c would be equal. So what is it saying? It says if you add or subtract a constant term from both sides of an equation, the equation remains true. So let's make up an example. Let's say a is equal to 2. Oops. A is equal to 2. B is equal to 3. C is equal to 5. So what we are saying, well, I cannot do that. A equal B, so this instead of 3, it has to be 2. So it says if A is equal to B, then A plus C equal B plus C. So A and B are equal to each other because 2 is equal to 2. 2 is equal to 2. So if to both sides of this I add a constant, a C, which is in this case 5, so 2 plus 5 would be equal to 2 plus 5. Right? 7 equals 7. It would also be true if you subtract the same thing from both sides. If A is originally equal to B and you subtract from both sides the same real number, the equation would still be true. In addition, if A is equal to B, again, A and B can be real number, it can be expression also. We're going to see that in just a second. If A and B are equal to each other and C is not 0, then A times C would be equal to B times C, and A divided by C would be equal to B divided by C. Okay? So what it's saying is if you multiply both sides of an equation by a constant, the equation is still true. If you divide both sides of an equation by a constant, the equation will still be true. Therefore, from all of this, if you add or subtract a constant to both sides of an equation, the equation is still true. If you multiply or divide by the same constant, the equation will still be true. So adding, subtracting, multiplying, dividing by the same term on both sides of the equation will still be true. We use this to solve an equation. So here's an equation. 3x minus 4 equals 5x plus 12. 3x minus 4 equals 5x plus 12. So what I'm going to do is, again, it might be just a little bit different. What I'm going to do is I'm going to add to both sides a 4. So you get 3x equal 5x plus 16. Okay? Now, you subtract 3x from both sides. 3x minus 3x equal 5x minus 3x plus 16. 3x minus 3x is 0 equal 5x minus 3x would be 2x plus 16. Okay. Now subtract the 16 from both sides. Subtract the 16 from both sides. So minus 16 here, minus 16 here. So 0 minus 16 is minus 16. Plus 16 and minus 16 cancel. So 2x equal minus 16. Divide both sides by 2. The equation still remains. So 2 and 2 would cancel. So you have x minus 16 divided by 2 is minus 8. That's the answer to this equation. That means if I plug in for x minus 8, the left-hand side would be equal to the right-hand side. Let's test it before we go to the slide. So x is equal to minus 8, so that means 3 times minus 8 minus 4 equal 5 times minus 8 plus 12. So 3 times minus 8 is minus 24. Minus 4 equal 5 times minus 8 is minus 40 plus 12. 24 minus 4 minus 24 minus 8 is minus 28 equal minus 40 plus 12 is also minus 28. So the left-hand side equals to right-hand side for this answer. So we tested that minus 8 and minus 8 does make the left-hand side of the equation equal to the right-hand side of the equation. Let's see what they did. You should have come up with the same answer. It might take in a little bit different ways of doing this, but the answer should ultimately be the same. So 3x minus 4 equal 5x plus 12. So they subtracted 3x from both sides. So they will make the 3x first. So they end up with 2x plus 12 on this side, minus 4 on this side. Now they subtract the 12 from both sides, minus 12, minus 12. So this would be minus 16. That would be 0. So 2x equal minus 16. Now divide by 2. X would be, or multiply by 1/2, either way. X would be equal to minus 8. That's the answer to this equation. Again, these are linear equations because the power here, as you can see, is 1. A nonlinear equation, again, those of you who have a graphic calculator, you can plug this and you would see this. This will not give you a straight line. It will give you a curve. That's why we call it a nonlinear equation. How do you solve this nonlinear equation? Square root of 4x plus 1 equal to 5, right? One way to solve it is square both sides. Square both sides. Okay, when you square both sides, the equality should remain the same. So when you square this, I really don't think this is a place for radical here, because radical is the topic of the next section. But nonetheless, when you have a square root and you square it, what happens is the square root sign would be lifted. So here would be 4x plus 1. And this 5 squared would be 25. Now you subtract 1 from both sides, 4x, subtract 1. This would be 4x because plus 1 and minus 1 would cancel, equal 24. Divide both sides by 4. X would be equal to 6. That's the answer to this equation. And again, I can go ahead and plug in for x in the equation 6 and see if it is true. So I would have square root of 4 times x. It would be 4 times 6 plus 1. Square root of 4 times 6 is what? 24 plus 1. Square root of 24 plus 1 is 25. What is the square root of 25? Is equal to 5. And that's what we had. So this actually does make the left-hand side equal to the right-hand side. So the answer is x equals 6. That's the correct answer. So as usual, we're going to go and see what the slide tells us, the way we solve it, or they come up with a different method of solving this nonlinear equation. Okay, let's go. Yeah, that's what they did. You square both sides. So you get 4h plus 1 equals 25, h equals 6. So that's what they got. They tested it, they checked it, and it was correct. That's the same checking we just did ourselves. Sometimes your equation might have several variables. If you have several variables, the problem should tell you to solve for which variable. Right? Up to this point, the only variable we had was x. Now you can have more than one variable. Okay, let's go ahead and solve it. Okay. Now here it says s equal 2 pi rh plus pi r squared. So we have s as a variable as unknown, 2 is a constant, is known, pi is a constant, is known, r is unknown, h is unknown, therefore variable, pi is known, and r is unknown. By the way, this is how you find the area of a cylinder. This is the formula for the area of the cylinder. It says solve for h. Solve for h, right? So the way we do it, we're gonna keep the term with h. Here happen to be only one. If we had more than one term with h, we factor h out and keep it on one side with the equation and take everything to the other side. Which, by the way, when you take something from one side of the equation to another side, the only thing that can happen is the sign would change. So if it was a positive, it would become negative. If it was negative, it would become positive. So what we're going to do is we're going to take this positive pi r squared to the other side of the equation. So it would be s minus pi r squared equal 2 pi r h. Okay? That's the first thing. Second thing, divide both sides by the coefficient of h. Coefficient of h. Everything else we treated like a constant now. So the coefficient of h we treated as a constant. What is the coefficient of h? Coefficient of h is this whole thing. So we're going to divide both sides by 2 pi r. Both sides. 2 pi r. So on the right-hand side, the 2 and 2 would cancel. The pi and pi would cancel. The r and r would cancel. You end up with an h. And that's what you were trying to solve for. You were trying to solve for h. So h would be equal to s minus pi r squared 2 pi r. You really cannot simplify too much from here. So that's the answer. You solve for h. So you figure you're telling yourself that the only variable I have here, is h. Everything else is treated as constant. Okay, let's see what they did. Okay, they did the same thing. They took this pi r squared to the left-hand side. It became minus pi r squared. So subtract pi r squared from both sides. And now divide everything by this coefficient 2 pi r. There you go. So you come up with this as the equation for h. So you solve for h. H has to be H has to be S minus pi r squared, 2 pi r divided by 2 pi r. Okay, so you solve for a specific variable. Let me go back and let's do this a little bit. We will do that later. Actually, the original equation is solving for S itself, right? So S is equal to this, so don't need to do that. Now we are going to get into nth root of a number. So this is where the radical sign comes in. Nth root of a number. Like the second root, the third root, the fifth root, the 10th root of a number. It says, this is how it is defined. If n is a natural number, we remember what natural numbers are, right? 1, 2, 3, 4, 5, 6, all the way to infinity. If n is a natural number, in other words, not negative, n is a natural number, and a and b are real numbers. A and b are real numbers. So they can be positive or negative. No problem with that. It can be a fraction. It can have decimal. It can be irrational. It can be rational, right? Real number. Such that a to the n equal b, then a is the nth root of b. The principal nth root of b is written as this. Okay? Here's an example. If a is equal to 2, b is equal to 3. No, b is equal to 8. You can do that. And n is equal to 3. Right? A is equal to 2, b is equal to 8, n is equal to 3. Right? So a is a natural number, 2. A and b are real number. I'm sorry, n is 3. n is 3. A and b are real number, 2 and 8. Such that a to the n power, what is a? 2. N is 3, is equal to b, that's what it says here, 8. Isn't that true? 2 to the third is equal to 8. So it is true. Then a is the nth root of b. Then a is 2, is the nth root, n is what? 3, of b. b is 8. So the third root of 8 is equal to 2. That's what this one-line explanation of what the nth root of a number is explaining. So we write it as the nth root of b. This is a radical with index n and radicand b. These are the name. A radical is this sign. The index is called n. Under the radical sign b is called the radicand. Just some definition. So here in this example it says square root. The only time you don't write the index here is when it's 2. So it is the square root of 81 is equal to 9. The third root of minus 8 divided by 125 is minus 2 divided by 5. In other words, if minus 2 divided by 5 multiplied by itself 3 times, this index, 3 times, you get minus 8 divided by 125. Okay. If you multiply 3 times, let me do that. multiply it by itself 3 times. Right? Minus 2/5 times minus 2/5 is plus 425. I take care of these two, which multiply by minus 2/5 again. First of all, the sign minus times plus would be minus. 2 times 4 is 8. 5 times 25 is 125. Right? So if you multiply 3 times by itself, you would get what you have under the radical, equal to the radicand. You should remember that square root of a negative number is not defined. You cannot take the square root of a negative number. In other words, you don't have any two real number, that if you multiply by each other, they give you a negative number, right? They cannot give you a negative. It would always be a positive number. As a matter of fact, not just the square root of a negative number does not exist, an even root of a negative number does not exist. An even root of a negative number does not. So a fourth root of 16, a fourth root of minus 16 also does not exist. An even number, right? Odd number is okay for a negative radicand, but not even index. Index cannot be even.